Hey geometry students, this is Coach Merlot, Mr. Merlot, with section 7.4 this week. Proud of you guys for hopping on here and trying some new remote learning. On this video, I'm doing it from my computer, and so I'll just be filling in the notes. We're going to be talking about special parallelograms, rhombus, rectangles, and squares. So let's get right into it. By the end of today's lesson, we'll be able to successfully use properties of a rhombus, rectangle, and square. The very first item that we're going to talk about is a rhombus corollary, and this is the number one thing that can help you identify what quadrilateral is a rhombus. So a quadrilateral is a rhombus if and only if it has four congruent sides. And we see here in this quadrilateral that AB, BC, CD, and DA are all congruent, which makes it a rhombus. Then we look into a rectangle, and a quadrilateral is a rectangle if and only if it has four right angles, or we could say if all of its angles are congruent. So four right angles, or if it's all four angles are congruent. So what makes a square? The analogy that I like to use is you have a rhombus and a rectangle. They get married and they make a square. The square has both the characteristics of a rhombus and a rectangle. So a quadrilateral is a square if and only if it is a rhombus and a rectangle. And so what are the key points to that? Well, a rhombus is an equilateral and a rectangle is equiangular. Therefore, a square is both. So logically, a square is a rectangle. All squares are rectangles, but not all rectangles are squares. Example 1, for any rhombus RSTV, decide whether the statement is always or sometimes true. Draw and sketch and explain your reasoning. So I'm trying to figure out if I can draw on here, but for now I'll just kind of verbalize with you. If we take a look at the rhombus RSTV, is it true that rhombus are equiangular? The answer is no. They could be, but that doesn't make it a rhombus. So we're going to say that it will sometimes be true because S and V are opposite angles in the rhombus. Scratch that. We're going to say it's always true because they are opposite. Now T and V, since they are next to each other or adjacent to, this is what makes it sometimes congruent. For any square CDEF, is it always or sometimes true that segment CD is congruent to segment DE? And the answer is always, because a square is equilateral. Example 2, classify the special quadrilateral. Explain your reasoning. We can take a look at the quadrilateral. We see these markings that signify each side is congruent. So we know for sure it's a rhombus, but could this rhombus also be a square? The answer is no, because in order for it to be a square, it'd have to have a right angle here. So the correct answer is a rhombus. And the reasoning is it's equilateral. B, a quadrilateral has 4 congruent sides and 4 congruent angles. Therefore, we know it is a square, and our reasoning is the quadrilateral is equilateral and equiangular. Now we have some theorems about these special quadrilaterals that deal with their diagonals. A parallelogram is a rhombus if and only if its diagonals are perpendicular. And the picture we have here, we can see that ABCD is a rhombus if and only if AC is perpendicular to BD. Our next theorem, a parallelogram is a rhombus if and only if each diagonal bisects a pair of opposite angles. ABCD is a rhombus if and only if segment AC bisects angle A and angle C, and BD bisects angle B and angle D. A parallelogram is a rectangle if and only if its diagonals are congruent. ABC is a rectangle if and only if diagonal AC is congruent to diagonal BD. Those are the notes for section 7.4. Next, I will show you how to fill out the foldable for a rhombus, rectangle, and square.